Okay, through the presentation, we'll go through the launch of our dedicated fishing solutions department. We'll go through some of the well technologies that currently exist that we're applying for the fishing services. I'm going to explain a little bit about impact. Again, it's important to understand the benefits, but also the disadvantages of impact versus straight pool. I'll go through some of the intelligent fishing BHAs that we're going to be launching. We'll go through a fishing case history, then obviously at the end there'll be a question and answer session. Welltech is a truly solution-driven company where over the past few years we have been performing fishing operations utilising our well tractors and well strokers. However, what we didn't have was a dedicated fishing department. Obviously that's changed, I've come on board. But what we're also going to be introducing is intelligent robotic fishing packages where we're looking to replace conventional heavy fishing methods with intelligent fishing BHAs and solutions. And looking at fishing operation, years gone by, it would typically have been done with drilling. Then we had the slick line and the E-line came on board, and braid line. From there, obviously, when they didn't have the required pull or impact, typically you would look upon coiled tubing as a solution. With the increase of extended reach in unconventional wells around the world, even coiled tubing nowadays is restricted or hampered by the actual overpull it can generate in depth due to the drag along the length of the coil. When we're talking about fishing, we're talking about restoring the wellbore access or production. If you're looking at what a fish consists of, it could be lost, dropped or stuck wire, cable, a tool string, a BHA, a lock mandrel, a bridge plug, be it permanent or retrievable, and even such things as capillary strings. If we go through the solutions that we've got on board just now, obviously we've got our conveyance solutions where we've got the well tractor for getting us on depth, even down to horizontal environments. We've also got the slickline tractor and coiled tubing tractor that can be also utilised for that. I'm just going to quickly read this out. Basically, we just beat our own world record a couple of months ago. Our colleagues in Abu Dhabi, where we tractored to a depth of 29,200 feet. For the mechanical solutions, we'll go through this in the subsequent slides, but we've got the well stroker and Welltech release device. When we're looking at fishing, obviously we've got the milling solutions, which we saw there just in that last presentation, where they can be applied in whole, but for the fishing side, we're more looking at attacking, for example, a permanent bridge plug, or it could even be a lock mandrel that we're going to have to mill something away from, where we'll also use the wells tractor for a weighting bit. We've got our clean out solutions. Again, I'm not going to go into the actual cleaning out other than, for example, there is fish down hole where there's been iron sulfide or scale or wax that's resulted in a tool string or even a lock mandrel stuck in hole. So we can obviously use our clean out solutions to get down hole to reach the fish. And then our intelligent robotic fishing BHAs we'll go through in the subsequent slides. When looking at a fishing job, the most important part of it is having a detailed chronology of what's led to the fish being left down hole. More often than not, we get half the picture. We'll be told, oh, we tried to set a lock, the wire snapped at surface, or we got stuck in the hole. But when you start digging back on the history, there's a causal factor. Admittedly, sometimes it's human error, but on the upside of it, there is also well conditions. It's important to know exactly what you're dealing with down hole. It's also so you understand what the fish is and the properties of the fish. So what we do is we actually send out a detailed questionnaire so we can get the full chronology of the well as far as relating to the fish itself, and then also of everything that is lost in the hole. Understanding the risks and knowing how to mitigate them, again, a crucial factor, but typically when you get hit with a fishing operation, it's normally live operations, and for example, slick line, E-line, braid line, or whatever have done something wrong or down to well conditions. People tend to react. Suddenly you're pulling together a little emergency group, the operator will discuss it, the service company will discuss it. Before you know it, you're just throwing stuff in the well without actually understanding the risks associated to that. Real-time diagnostics is important. Again, for example, like we said with the confusion block, the LIB, it's understanding what that run tells you to in turn decide what to run next. Again, there's a lot of misconceptions over, oh, here was the results of this run, here's what we should do next, and they're not actually realising the risk that they're putting themselves into doing that. Impact force. Remember, I'm from a slickline braid line background. It's what I lived by. It was the only way with the slickline braid line that you can create any sort of significant forces down hole, because obviously you're limited with the pull on your wire. Well, when you look at an impact force, it's correlated in a rule of thumb calculation. It's basically a number multiplied by your jar setting to give you that impact down hole. Obviously different factors for in gas or in fluid, but it's not an actual true figure of what you're generating down hole. When you look at an impact force, it's over a very short period of time. It's gone as quick as it's happened. It's basically the peak impulse of the impact itself. But when you look at that impulse of force, you can actually get impacts that are higher than the yield or even the UTS of an object down hole, and it doesn't do anything to it because of the length of time of the impulse of force. So again, although it's a good solid force, the actual effect on a fish down hole is minimal, to the extremes of it works better on a solid target. When I'm saying a solid target, we're talking about a lock mandrel that's set in the well. You've got a moving fish, you'll find impact actually absorbed and it dissipates. Also, when you look at impact, it creates a recoil. Obviously, you've got your accelerators typically when you're looking at higher impacts, which also acts as a shock absorber. However, you will get a recoil to a point where you can prematurely shear your BHAs or even your weak point in your rope socket. Okay, what we've done here is the top line, the green line, we're basically doing a comparison over stroke force versus an impact force. The green line represents our 3.5-inch well stroker, 100,000 pound straight pull. What we've based this against is 7/32 galvanized diform wire with a 2.5-inch tool string. As you can see at surface, you're limited to about 90,000 pound impact in gas, and you lose about 20% of that impact force in fluid. Again, remember, this is rule of thumb calculations, and to be fair, there is obviously stronger wires and bigger and higher impact tool strings down hole. So this next one, I will show you 5/16 high strength galvanized wire. It's basically the strongest wire that they're using today for fishing operations, albeit there's now 7/16 wire now getting deployed. Again, this is with a 2 11/16 smart high-load tool string, where at surface you can get up to 150,000 pound impact in gas, 120,000 pound in fluid. But as you can see, the deeper you go down the well, you start to lose that applied impact. That's based obviously on your jar setting that you can achieve. But in reality, I've actually been in fishing jobs where the impact has been as low as 50,000 pounds at 13,500 feet. Again, due to the drag effect and obviously the jar impact that you can actually achieve down hole. And again, this is a rule of thumb calculation. This isn't actually a proven impact. Okay, we use the well stroker. Our 3.5, it can give us up to 100,000 pound of finely tuned direct axle force. As was mentioned in the previous presentation, it works by basically gripping itself against the tubing wall. And what we've got is a surface readout where we can adjust the stroke as far as the stroke pressure or stroke force, where we can dial in, for example, an initial stroke of 20,000 pounds. If we want to go harder, we can basically, from surface, change the settings all the way up to 100,000 pound stroke. Also, for the surface readout, it'll also show us the actual distance that the piston's actually stroked. So again, we can see any movement of the fish. It mitigates the requirements at surface of heavy rig-ups and larger pools, obviously, because you're not looking to do anything from surface other than convey yourself to depth. All the forces are actually generated down hole. It mitigates the risks of shock shearing your BHAs. Again, as we said, with the impacts, you get a recoil. With this, it's just a straight pull. Also, the force reaches the stuck point, as in it's not dissipated. If we, for example, dial in 50,000 pound stroke, be it upward or downward, the stroker will pull up to the 50,000 and it will stop itself, but if the fish was to move, as in if you drag up the hole or the opposite pushing down hole, the tool will keep kicking itself back into the required dial setting. And also, obviously, through that, it's not going to dissipate, obviously, on a softer moving target. When you're looking at fishing, it's important, obviously, your primary tool will be your fishing tool, be it a heavy-duty pulling tool or a spear, an overshot. That's your primary means of release, assuming it's a releasable fishing tool. But directly behind that, you always want to have a backup release device. Remember, you're fishing, you're generating a lot of force against a fish, as in, let's say, for example, you're latched onto a cable head or a rope socket, depending on what you want to call it. As you're generating that amount of force, you could actually lip the fish neck, and it could transpire that if you had to release off the fish neck, the tool might not be able to because of the damage to the fish itself. So obviously you've got a backup release behind that. As well, you're typically looking for one below your cable head or your rope socket on braided cable operations. With the WRD, we can run multiple multiple Well-Tech release devices in our string. They're set on a timer where we correlate that on surface, where we can set it to 12 hours, for example, 24 hours, run in the hole, perform a fishing job. If we were to lose telemetry of the tool string, if we wait for the timer to go through, it'll release itself. So obviously the timer we could put on the fishing BHA, for example, we could set to 24 hours, the one on the cable head 36 hours. So if we were to lose communication or become stuck in the hole, there is a fail-safe, but the opposite side to it is we can reset that timer. Let's say we set it to 12 hours, we're working on a fish, we're actually managing to drag the fish up the hole. If it's going to take longer than what we set the WRD2, we can actually reset the timer from surface. But also, we can actually activate the Well-Tech release device, as in if we choose to release, we don't need to wait for the timer. We can send a command to release. On release, it leaves the external fish neck on the bottom half of the tool for subsequent release retrieval. Also, the fact that it's not pinned, again, there's no risk of premature shearing, be it through shock shearing, but also, for example, pulling up or pushing down. It doesn't matter which way we're pushing or pulling with the Well-Tech release device, that there is no pins or release mechanism that's going to prematurely activate. Electro-release fishing tool. Again, up until today, most people have been using mechanical type fishing tools that are with shear pins, or in the case of coiled tubing, flow release activated fishing tools. What we're looking to bring to market is an electro-release fishing tool, where, as you can see, the main tool itself, you change the BHA that's screwed onto the bottom of that. So what you can have is a heavy-duty pulling tool as an external catch, or like a GDC, for a standard fish neck. We can change the bottom sub to an overshot, where now, obviously, it's the same tool, but with an overshot mechanism on it. The same for internal catch. We can put a GS assembly in the bottom, covering lock mandrels or sleeves. And again, if we're looking at a damaged fish neck, we can then change that BHA to a spears type with slip assembly. It's got a safe working load of 100,000 pounds again, so a perfect match for use with the Well stroker. It's also got a fail-safe as far as we can release on command, but it's got a timer actuated where if we're to lose tool string telemetry, we can actually just wait for the timer to release. Again, with it not having any shear pins, when trying to bait onto a fish, you're not worried about prematurely shearing the BHA. The added benefits to that as well is that we can actually retract the dogs or the slips to engage onto a fish. Also, if we're working on a fish, we can soft release, pick up, let's say for example there's a tool string stuck in sand, we could then circulate the well, pick ourselves clear of the fish, but we're not having to come out whole to repin the tool. We could then go in and re-engage the fish again. Again, it has adjustable reach, not so critical for shearing off, obviously, because we're just sending a command, but it's more for where we want to position specifically slips, for example, be it internal or external. And then we've got a range of bell guides we can put on the bottom as well. Additional to that, within the fishing packages, we'll also have your more conventional type fishing BHAs. For example, wire brush. This is more to do with tool string protection, as far as we can put that behind a fishing BHA just to protect ourselves going down past wire. The lead impression block, stroke confusion block. I agree, sometimes it is misleading or it's difficult to interpret. However, where possible, we will actually run a camera. High power magnets, self-explanatory, but it's for picking up little bits of debris as we're breaking a fish apart. Dummy rope socket, that's purely for baiting a different fishing BHA on the bottom of our electro-release fishing tool or even onto a heavy-duty pulling tool. A range of crossovers, we're only going for the sucker rod type crossovers because there's that many different quick connect type connections offshore or in the world globally that what you will find is everybody's got the same sucker rod, so obviously we can just use their crossovers to cross back to any weird connection that they might have. We've also got our own design and engineering base. We're based in Allerød in Denmark, where we can actually come up with bespoke solutions where you can see the bottom right, that was actually a tool that we made for retrieving a permanent bridge plug that would milled out. On top of that, we've also got a completions assembly manufacturing in Esbjerg in Denmark. Just to go look through a little fishing job here, just to show, again, the advantages of straight pull over an impact. Slick line is running the hole of an 1'7" tool string. The sets of memory gauges at 11,500 feet. Whilst pulling at the hole, the tube and retrievable safety valve, it closed in on the wire and it resulted in the wire getting cut. So there's 5,150 feet of slickline lost in the hole. Initially, they rigged up 3/16 braided line to go fishing, but if you look at the minimum breaking load of the slickline that's lost in the hole, it's 2,700 pounds. What they'd done was basically they had a jar that was set for £1,000 trying to fish wire. For fishing wire, you're relying on a straight pull. Impact actually is probably the worst thing you can do fishing wire. Not to say that sometimes you don't need to apply impact. But anyway, because they were tripping the jars, it was snapping the wire grab, and they're getting very slow and very little returns from the fishing operation. They did rig up 5/16s. However, what they did wrong was they were running a wire finder to ball up the wire, but what they were doing was they were getting a wee bit excited in how much they were balling, and basically they were balling it into tight, big balls. Then they were running a spear into that to try and fish the wire. Obviously, one of the runs, they ended up with a spear stuck inside the actual slickline ball. Filling their jars at £6,000 and applying £8,000 overpulls, they couldn't recover the spear. They were at a stop. So they rigged up coil tubing on the well. And again, coil tubing firing their jars at £10,000, applying straight pulls of up to £14,000. Again, no success. When I'm saying firing, be it the braided line or the coil tubing, firing the jars that's the overpull. That's not the impact. The impact would be considerably greater. But as we said, an impact's not very good on a soft or a moving target. Anyway, we'd rigged up, ran the well stroker, the 2.5 well stroker, so it only goes up to £24,000 stroke, and basically recovered it in one run, where multiple runs had been tried with braided and coil tubing. So just to go over what we've just seen, we now have a dedicated and experienced T-line fishing solutions department. We'll have the well tractor, the well stroker, and the well tech release device, which are adapted for electroline operations. We've gone through the benefits of direct linear pull over impact. The milling and cleaning solutions, which can again be adapted to your fishing operations. The advantages of intelligent fishing BHAs. And basically it all relates to a versatile solutions platform, where it doesn't matter which direction the fishing operation takes, you're not having to have multiple service providers or solutions on location. With E-Line, we can kind of do everything now that we never used to be able to do. And then obviously we went through a fishing operation case history just to show where direct linear pull can have a better result than an impact.